A black hole remains a silent testament to the extreme gravity that governs our vast universe. Light cannot escape the pull once it crosses the invisible border known as the event horizon. Astronomers use massive radio telescope arrays to capture the glowing silhouettes of these very distant objects. You might find the concept of a singular point of infinite density quite difficult to grasp. General relativity suggests that space and time curve deeply around these heavy, dark, and invisible anchors. Looking into the void requires a patient mind willing to accept the strange laws of physics. The environment around a singularity is surprisingly quiet, despite the immense forces acting upon nearby stars. Every galaxy seems to host a central giant that keeps the stellar neighborhood in a balance. This gentle broadcast will explore 110 relaxing facts about these dark cosmic wonders. We shall begin by considering the way gravity shapes the very fabric of our shared reality. Please settle into a comfortable position as we drift through the silent reaches of the cosmos. The vacuum of space provides a perfect backdrop for understanding the most mysterious entities ever discovered. Scientists continue to refine their models to better describe how matter behaves under such extreme pressure. You are invited to listen closely as we unravel the delicate threads of modern black hole. We will move slowly through each observation to ensure a peaceful and very steady mental pace. This journey is designed to help you release the day while contemplating the scale of infinity. Our understanding grows with every new image captured by the sophisticated sensors of the James Webb. We are merely observers on a small blue planet, looking out at a grand and ancient. The darkness is not a wall, but a window into the fundamental nature of the entire. Let the steady rhythm of these facts carry you toward a deep and very restful sleep. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. Deep within the cosmic void, ancient light bends around the curved edges of an invisible sphere. Gravity pulls at the stars while time begins to slow down near the dark, heavy center. We watch the distant glow of hot gas as it spirals slowly toward the dark abyss. Your mind can drift among the stars while we ponder the silent secrets of the deep. To understand the density of a black hole, we might look at the objects in your own room. Imagine taking a common household item, like a heavy iron paperweight or a small ceramic cup. If you were to compress the entire Earth down to the size of a single marble, it would become a black hole. This comparison helps us visualize how much matter is packed into such an impossibly small, dark space. The gravity of such a marble would be just as strong as the Earth's current pull. However, you would have to be incredibly close to that marble to feel its true intensity. Think of the way a heavy bowling ball rests upon a soft, supportive mattress in your home. The fabric dips and curves around the weight, creating a gentle slope that pulls nearby objects in. This is much like how a black hole curves the fabric of space-time around its central point. If you were walking toward one at a human pace, the transition would feel very gradual. At a great distance, a black hole behaves just like any other mass in the quiet sky. It is only when you approach the edge that the nature of time begins to change. Imagine a clock sitting on a shelf, ticking away the seconds of a long, peaceful afternoon. As that clock moves closer to a source of extreme gravity, its ticking would appear to slow. To a distant observer, the hands of the clock would seem to move through honey, thick and viscous. Eventually, the movement would appear to stop entirely, frozen in a single, quiet moment of eternal rest. This slowing of time is not a trick of the light, but a physical reality. It reminds us that our perception of a steady now is tied to where we stand. In the presence of a giant, time stretches out like a long shadow at the end of the day. To understand the weight of such an object, think of a simple kitchen sponge. If you were to squeeze that sponge in your hand, it becomes smaller and denser, yet its mass remains the same. Now, imagine if you could squeeze the entire mass of a mountain into a single grain of sand. This grain would be so heavy that it would slip through your fingers, through the floor, and deep into the earth. A black hole is the ultimate version of this compression, where matter has folded inward until it occupies no space at all. We call this the singularity, a point where the familiar rules of our physical world simply pause. It is a quiet place where the math we use to describe the universe reaches a gentle, silent limit. Imagine walking along a shoreline where the sand is perfectly smooth and the water is still. As you walk toward the ocean, the slope of the beach becomes slightly more pronounced with every step. At first, you barely notice the change, but soon you find your pace slowing as the gravity of the water pulls at your feet. A black hole creates a similar slope in the fabric of the universe, a curve that directs everything toward its center. If you were to drop a small pebble into this curve, it would not fall straight down, but would spiral in a long, lazy circle. This movement is predictable and steady, a rhythmic descent into the heart of the dark. Think of a heavy velvet curtain hanging in a quiet, dimly lit theater. If you place a small lead weight into the folds of the fabric, the velvet stretches and sags under the pressure. This stretching represents the way a black hole distorts the dimensions of length, width, and height. To an observer standing far away, an object approaching the black hole would appear to stretch out like a piece of warm taffy. This process, which scientists sometimes call spaghettification, happens so slowly and smoothly that it feels like a natural extension of the space itself. There is no sudden jerk or snap, only a gradual lengthening into a thin, shimmering thread of light. In our daily lives, we think of a second as a fixed and unchangeable unit of measurement. We set our watches by it, and we feel its steady pulse in the beating of our own hearts. But near a black hole, the very concept of a second becomes fluid and soft, like wax melting in the sun. If you were to spend an hour near the edge of a massive black hole, years might pass for your friends back on Earth. When you returned, you would find the world moved on, while you remained essentially unchanged by the passage of time. This is the mystery of relativity, a gentle reminder that the universe does not keep a single, universal clock. Consider the way a magnifying glass bends the light from a nearby lamp to create a bright, focused point. A black hole acts as a cosmic lens, bending the light of distant stars that pass behind it. This creates a shimmering ring of light, a halo that glows with a steady and ancient brilliance. We call this an Einstein ring, a visual proof that gravity can warp the path of a photon. The light does not travel in a straight line, but follows the curve of the space-time that the black hole has shaped. It is a beautiful, silent distortion that allows us to see the invisible through the behavior of the visible. If you were to toss a letter into a campfire, the paper turns to ash, and the information written on it seems to vanish. Scientists have long wondered if the same thing happens when information falls into a black hole. Is the history of an object lost forever, or is it stored somehow on the surface of the event horizon? This is known as the information paradox, a quiet debate that has lasted for decades among the greatest minds in physics. We accept this uncertainty with a sense of calm curiosity, knowing that the answers may lie in a new understanding of reality. Perhaps the black hole is not a consumer of information, but a vast and silent library of everything it has ever touched. Imagine a large, spinning top moving across a wooden floor in a series of wide, graceful loops. As the top spins, it drags a small amount of the air around it, creating a tiny, invisible whirlpool. A rotating black hole does something similar to the space around it, a phenomenon known as frame dragging. It literally pulls the fabric of space and time along with it as it turns, twisting the universe into a gentle spiral. If you were floating nearby, you would find yourself being carried around the black hole even if you were standing perfectly still. It is a slow, rhythmic rotation that governs the movement of everything in the local neighborhood. The event horizon is often described as a point of no return, but it is better thought of as a transition. It is the boundary where the escape velocity required to leave exceeds the speed of light itself. Since nothing can travel faster than light, nothing that crosses this line can ever find its way back to the outside world. Yet, from the perspective of someone crossing the line, there might be no physical marker or sign at all. You would simply continue your drift, moving deeper into the shadows while the universe behind you begins to fade. It is a peaceful departure from the known, a movement into a realm where the future and the past become one. Think of the way a deep, wide river flows toward a distant waterfall in the mountains. Far upstream, the water moves slowly, and you can swim against the current with ease. But as you get closer to the edge, the flow becomes stronger and more insistent, pulling you toward the drop. The event horizon is like the very edge of that waterfall, the place where the current becomes absolute. To someone watching from the shore, you would appear to slow down as you reach the brink, eventually becoming a still image. But to you, the water remains calm, and the transition over the edge is just another part of the long, steady journey. In the silence of the vacuum, black holes are not truly black, but are often surrounded by the most energetic processes in the universe. Massive jets of particles can be shot out from the poles of a spinning black hole, traveling across millions of light years. These jets are powered by the immense gravitational energy of the material falling inward, twisted by magnetic fields into tight, glowing beams. They act as cosmic lighthouses, signaling the presence of a giant in the dark heart of a distant galaxy. Despite their power, these jets move with a consistent, unwavering, steady flow that spans across the deep time of the cosmos. We often imagine space as an empty void, but it is more like a physical material that can be stretched, twisted, and torn. A black hole is the place where this material is stretched to its absolute breaking point. Yet, even in this extreme state, there is a sense of order and mathematical beauty to the way it behaves. Every black hole can be described by just three simple properties: its mass, its spin, and its electric charge. This simplicity is a profound realization, suggesting that at the deepest levels, the universe is governed by very few rules. We find comfort in this simplicity, as it allows us to map the infinite using the tools of human logic. As we conclude this exploration of the human scale, let your mind rest on the image of a single star orbiting a dark center. The star moves in a perfect, repeating ellipse, never faltering and never rushing its long journey. It is held in place by an invisible hand, a balance of motion and gravity that has lasted for billions of years. You are like that star, moving through your own life with a steady rhythm that is connected to the wider universe. The black holes are not monsters to be feared, but natural parts of a grand and ancient system. They are the anchors of the galaxy, the silent guardians of the deep, and the ultimate expression of nature's power. Now, as the scale begins to expand once more, we prepare to move outward into the wider reaches of the galactic neighborhood. The transitions are soft, like the fading light of a long summer evening as the stars begin to appear. We leave the familiar world of clocks and sponges behind, drifting toward the giant structures that shape the destiny of the cosmos. Every step is taken with a quiet breath, a slow movement toward the heart of the mystery. The universe is waiting for us, calm and vast, ready to reveal its secrets in its own patient time. To move outward, we must first look at the stellar mass black holes that pepper our own Milky Way like invisible weight-bearing pillars. These are the remnants of stars that were once 20 or 30 times the size of our Sun. When such a star exhausts its nuclear fuel, it can no longer support its own immense weight. It collapses in on itself, a process that happens with incredible speed but leaves behind a silence that lasts for billions of years. Imagine a grand cathedral made of light and glass, suddenly folding into a single microscopic point of lead. The structure is gone, but the presence of its weight remains, warping the air around it. As we drift away from the comfort of our solar system, we encounter the first of these dark neighbors. They are scattered throughout the spiral arms, often hidden within thick clouds of interstellar gas and dust. We know they are there because we see the gas being pulled toward them, spiraling inward like autumn leaves caught in a gentle backyard whirlpool. The gas heats up, emitting a soft X-ray glow that allows our telescopes to map the location of the invisible. It is a slow and rhythmic consumption, a steady transfer of matter from the visible world into the unseen depths of the singularity. Consider the relationship between a black hole and a companion star. In many cases, these dark objects are not alone. They dance with a living star in a tight, gravitational embrace. The black hole acts as a silent partner, slowly drawing a thin stream of plasma from the star's outer atmosphere. This stream forms a disk, the accretion disk that we discussed earlier. From a human perspective, this process is incredibly slow. It would take millions of human lifetimes for the black hole to finish its meal. This slow pace is a hallmark of the cosmos. There is no sense of urgency, only the inevitable and patient pull of gravity. As we move further out, the distances between these objects begin to grow. We leave the dense clusters of stars and enter the vast, cold spaces between the spiral arms. Here, the vacuum is almost perfect, yet it is still governed by the same laws of physics. Even in the emptiness, the presence of a distant black hole can be felt. It acts as a lens, subtly distorting the light of the galaxies that lie millions of light years beyond it. You might imagine space as a sheet of thin, clear ice. A black hole is a slight depression in that ice, a place where the surface curves just enough to change the path of a sliding stone. The movement through the galactic neighborhood is a movement through history. Every black hole we pass is a tombstone for a star that lived and died long before humans ever looked at the sky. They are the elders of the galaxy, the final state of matter that has seen the beginning of our world and will see its eventual end. There is a sense of safety in this permanence. The universe is not a chaotic place of random events. It is a structured environment where every ending is a new, stable beginning. The black hole is the most stable state of all, a place where change has reached its final, quiet conclusion. Think of the way a heavy snowfall muffles the sounds of a busy city, turning everything into a soft, white landscape of silence. The gravity of the galactic neighborhood acts in a similar way, smoothing out the fluctuations of the stars and creating a steady, rhythmic flow. As we drift, we notice the way the stars are organized into long, sweeping streams. These streams are guided by the overall mass of the galaxy, a mass that is anchored by the dark objects at its heart and scattered throughout its arms. You are a part of this flow, moving with the same grace and inevitability as the light itself. The transition from the human scale to the galactic scale requires us to let go of our traditional measurements of distance. We no longer speak in miles or kilometers, but in the time it takes for light to travel across the void. A light year is a distance so vast that it is difficult to visualize, yet it is the basic unit of our cosmic neighborhood. To move 1 light year is to step back in time by 1 year. As we move outward, we are looking further and further into the past, seeing the universe as it was when the light first began its long journey toward us. This is the beauty of the cosmic perspective. To look out is to look back, and to look back is to understand our origin. In the heart of these observations is a mild, unresolved mystery. Why do some stars become black holes, while others become neutron stars or white dwarfs? We know it has to do with the mass of the star's core, but the exact boundary, the limit of stability, is a subject of ongoing study. We accept this uncertainty, knowing that nature does not always provide sharp lines. There is a grey area where the matter is squeezed to the very brink of collapse, and it is in these liminal spaces that the most interesting physics occurs. We observe the pulsar, the magnetar, and the black hole, and we see them as part of a single, continuous spectrum of density. As we continue our drift, the scale expansion loops begin to overlap. We see the small black holes feeding on their companions, and we see the larger black holes anchoring the clusters. The patterns are the same, only the magnitude has changed. The same spiral motion, the same bending of light, and the same slowing of time occur at every level. This fractal nature of the universe is a source of great comfort. It suggests that if we can understand the small, we can begin to understand the large. We are scaling the heights of infinity by looking at the shadows in our own backyard. The galactic neighborhood is a place of deep drift and quiet contemplation. Here, the stars are like grains of sand, scattered on a dark velvet cloth. Each grain is a sun, and each sun has its own story, its own planets, and perhaps its own life. But from our perspective, they are all part of the same grand design. The black holes are the punctuation marks in this design, the places where the story takes a deep breath and pauses. They provide the contrast that makes the starlight so beautiful. Without the dark, we would not appreciate the light. Without the void, we would not appreciate the matter. Imagine the way a large ship leaves a wake in the water, a series of ripples that spread outward long after the ship has passed. A black hole moving through the galaxy leaves a similar wake in the distribution of stars. It pulls at the stars as it passes, subtly shifting their orbits and creating a trail of gravitational memory. We can map these wakes to find the black holes that are traveling alone, the rogue singularities that drift through the dark like silent nomads. They are the lone wanderers of the cosmos, carrying their secrets with them as they move from one arm of the galaxy to the next. As we prepare to step even further back, we take one last look at the stars of our neighborhood. They are bright, vibrant, and full of energy. But we know that beneath their light lies the potential for the dark. Every star is a future remnant, and every remnant is a testament to the endurance of the universe. We move outward now, leaving the familiar constellations behind and looking toward the vast, dark spaces between the galaxies. The transition is soft, a slow fading of the local light into the deep, ancient glow of the cosmic background. The universe is waiting, and we are ready to move deeper into the heart of the mystery. We begin our expansion by looking at the life of a single, massive star in the void. When a star much larger than our Sun reaches the end of its long life, it collapses. The outer layers are shed in a beautiful explosion, while the core falls inward upon itself. This process is inevitable, a natural conclusion to millions of years of burning bright and hot. We understand that only the most massive stars have the strength to create a true singularity. Yet, there is a mild mystery in the exact mass required to trigger this final, dark transformation. We accept this uncertainty, knowing that the universe holds its secrets behind a veil of gravity. Now, let us move outward to the neighborhoods surrounding these fallen stars. Around many black holes, there is a swirling ring of gas and dust known as an accretion disk. This material orbits the center like water circling a drain in a slow, rhythmic, hypnotic motion. Friction within the disk causes the gas to heat up, glowing with a soft, steady radiance. This light is often the only way we can find the black hole against the dark. Scientists study the flickering of this light to calculate the speed at which the disk is spinning. There is a quiet puzzle regarding how magnetic fields organized within the disk influence the flow. We observe the glow and wait for more data to clarify the movements of the invisible. This brings us to a larger scale, where black holes influence the movement of entire systems. In the heart of almost every large galaxy sits a supermassive black hole of incredible scale. These giants are millions or even billions of times more massive than our Sun, sitting in silence. Our own Milky Way is home to Sagittarius A, a gentle giant that anchors our spiral home. We understand that these central black holes play a vital role in how galaxies grow and evolve. However, we do not yet fully know if the black hole or the galaxy came into existence first. This chicken or the egg mystery is a fundamental question that cosmologists ponder during long nights of study. We accept the gap in our history and continue to map the stars that dance nearby. To understand that, we need to step back and look at the black hole as a gateway. Imagine a grand ballroom where the floor is made of velvet and the dancers move in long, sweeping arcs. In the center of this room stands an invisible conductor, someone whose presence is felt only by the way the dancers lean toward the middle. This is how we perceive the supermassive black hole at the center of our Milky Way. We cannot see the object itself, but we watch the star's massive, bright suns as they whip around a seemingly empty patch of space at incredible speeds. Their orbits are the signatures of a mass so concentrated that it defies our common understanding of matter. To look at these orbits is to see the invisible hand of gravity at work, guiding the stars in a rhythmic, eternal loop. As we move our perspective further out, we see that this relationship is not unique to our home. Every bright island of stars in the deep sky seems to have a similar anchor. These anchors are the engines of galactic evolution, quietly regulating the birth of new stars. When a supermassive black hole becomes active, it consumes the surrounding gas, heating it until it glows brighter than the rest of the galaxy combined. This process, while energetic, acts like a thermostat. It pushes away the excess gas, preventing the galaxy from growing too quickly or becoming unstable. It is a slow, self-regulating cycle that ensures the longevity of the cosmic neighborhood. Consider the sheer volume of space that a galaxy occupies. If a galaxy were the size of a vast city, the central black hole would be no larger than a single grain of sand in the town square. Yet, that grain of sand holds the entire city together, dictating the movement of every street, every building, and every light. We call this co-evolution, a term that suggests the black hole and its host galaxy grew up together, maturing in tandem over billions of years. There is a quiet beauty in the idea that something so small can influence something so vast. It reminds us that in the universe, importance is not always measured by physical size, but by the depth of one's influence. To understand the scale of these giants, we must look at the giants among giants. In the galaxy M87, located 55 million light-years away, sits a black hole 6 billion times more massive than our Sun. This was the first black hole ever to be photographed by humanity, a feat achieved by linking radio telescopes across our entire planet. The image shows a dark shadow surrounded by a ring of orange light, the shadow of the event horizon. Looking at this image is like looking back into the deep history of time itself. The light we see began its journey toward us when the dinosaurs still walked the Earth, traveling through the cold, dark of space to finally reach our eyes. The existence of such massive objects in the early universe presents a calm, unresolved mystery. We see them in the very distant past, already billions of times more massive than they should be according to our current models of growth. It is as if they appeared fully formed, like ancient ruins discovered in a forest that is only a few years old. Scientists call these seed black holes, and we are still searching for the process that allowed them to grow so large, so quickly. We accept this uncertainty as a part of the unfolding story of the cosmos, a puzzle that requires more observation and a more patient mind. Imagine the universe as a vast, dark ocean where the galaxies are small ripples on the surface. Beneath the surface, the supermassive black holes are the deep currents that move the water in ways we are only beginning to map. These currents connect the small scale of a single star to the large scale of the cosmic web. We see evidence of these connections in the way galaxies cluster together, drawn toward one another by the combined gravity of their dark centers. It is a slow, inevitable convergence, a drifting together of islands in the night. As a black hole spins, it creates a region called the ergosphere, where space itself is forced to rotate. If you were to hover in this region, you would find it impossible to stay still, even with the most powerful engines. You would be swept along by the rotation of space, a passenger on a journey dictated by the spin of the singularity. This effect, though extreme, is a natural consequence of the way mass interacts with the fabric of reality. It is a reminder that the universe is not just a container for things, but a dynamic, moving substance that can be twisted and turned. Now, think of the way a ripple moves across the surface of a pond after a stone is thrown. When two supermassive black holes collide, they create ripples in the fabric of space-time that travel across the entire universe. These are gravitational waves, and they are the heartbeat of the cosmos. We detect them as tiny, rhythmic stretches and squeezes of the Earth itself, movements so small they are measured in fractions of an atom's width. These waves tell us of the most violent events in the universe, yet they reach us as the gentlest of whispers. They are the songs of the giants, echoing through the halls of time. The scale of expansion continues as we look toward the Great Attractor, a mysterious region of space that is pulling our galaxy and thousands of others toward it. At the heart of such massive concentrations of mass, black holes are the silent architects of the structure of the universe. They define the voids and the filaments, the empty spaces and the crowded clusters. To study them is to study the blueprint of everything that exists. We step back once more, seeing the black holes not as destructive forces, but as the quiet foundations upon which the entire cosmic stage is built. Transitions between these scales must be handled with care, as the mind needs time to adjust to the vastness. We move from the center of our galaxy to the edge of the observable universe, following the light of quasars, the brilliant beacons powered by black holes in the ancient past. These quasars allow us to see the state of the universe when it was only a fraction of its current age. They are like candles lit in a dark room, illuminating the walls so we can see the shape of the space we inhabit. We look at them and feel a sense of continuity, a bridge between our small moment in time and the infinite reaches of the history that preceded us. Every subtopic we explore brings us back to the same conclusion. The universe is far more complex and far more peaceful than it first appears. The mystery of the black hole is a gateway to a deeper understanding of gravity, time, and light. We do not need to have all the answers today, for the stars are not in a hurry, and neither are we. We accept the mild, unresolved questions, the nature of the singularity, the origin of the first seeds, the final fate of information, and we find comfort in the search itself. As we drift further into the scale expansion, the details of individual galaxies begin to blur. We start to see the universe as a single, unified system, a vast tapestry of light and shadow. The black holes are the threads that hold the tapestry together, the dark weave that gives the light its form. We move outward, beyond the clusters and the superclusters, until the entire universe is visible as a soft, glowing web. This is the ultimate perspective, a view of the cosmos that is both overwhelming and deeply soothing. When we stand back at this distance, the individual giants we studied, the massive anchors of the Milky Way, or the towering void of M87, become small, pulsing points of gravity within a much larger structure. Imagine a vast, delicate lace draped across the vacuum, where every intersection of the thread is marked by a cluster of thousands of galaxies. These intersections are where the supermassive black holes congregate, working in silent unison to pull matter toward the nodes of the web. The space between these threads is empty and vast, known as cosmic voids, where almost no stars shine. These voids are the breaths between the notes of the cosmic symphony, providing the necessary silence for the structure to exist. To understand the scale of this web, you might think of a morning dew on a spider's web in a quiet garden. Each droplet of water represents a supercluster of galaxies, shimmering with the light of trillions of suns. Within each droplet, the black holes act as the surface tension, holding the galaxy together and preventing the stars from drifting aimlessly into the grey morning mist. As you pull back further, the individual droplets merge into a single, unified pattern of silver and shadow. You realize that the universe is not a collection of isolated objects, but a living, breathing network of connections. This brings us to the concept of the Great Attractor, a mysterious gravitational anomaly located deep within the Laniakea supercluster. It is a point toward which our galaxy and hundreds of thousands of others are drifting at incredible speeds. While we cannot see the Great Attractor directly due to the dust of our own galactic plane, we feel its influence in every movement of the stars. Scientists suspect that at its heart lie massive concentrations of matter and perhaps the most ancient and largest black holes in existence. We accept this hidden influence with a calm heart, recognizing that there are always larger forces guiding our path through the dark. Consider the way a slow-moving river carries a leaf toward the sea. The leaf does not fight the current, it simply exists within the flow, turning gently as the water moves. We are like that leaf, and the cosmic web is our river. The black holes are the deep channels where the current is strongest, providing the underlying momentum for the entire system. There is no friction in this movement, no heat, and no noise. It is a frictionless slide through the dimensions of space-time, a journey that takes billions of years to complete. By visualizing this flow, you can feel your own sense of urgency dissolve into the steady, unwavering pace of the cosmos. As we observe the web, we notice a subtle, unresolved mystery regarding the nature of dark matter and its relationship to black holes. We know that dark matter provides the invisible scaffolding for the cosmic web, but we do not yet know if primordial black holes, born in the first seconds of the Big Bang, might make up a portion of this mysterious substance. These tiny giants, no larger than an atom but with the mass of a mountain, could be scattered throughout the universe like invisible dust. We accept this possibility with a quiet curiosity, waiting for the sensors of our satellites to confirm what our math suggests. The scale of the universe is so vast that even light, the fastest thing we know, takes billions of years to cross the gaps between the filaments. When we look at the most distant parts of the web, we are looking at the universe as it appeared shortly after its birth. We see the first generation of black holes beginning to form, drawing the first clouds of hydrogen into the tight, glowing knots that would eventually become the first galaxies. This is the cosmic continuity in action, a slow, inevitable progression from simplicity to complexity, guided at every step by the hand of gravity. Think of the way a heavy weight placed on a trampoline creates a deep, smooth curve in the fabric. Now, imagine millions of these weights, of different sizes, scattered across a trampoline that stretches to infinity. This is the gravitational landscape of the universe. Some curves are shallow, created by single stars. Others are deep and sharp, created by black holes. The cosmic web is the result of these curves overlapping and interacting, creating a terrain of peaks and valleys through which the light must travel. It is a beautiful, invisible geometry that defines the shape of everything we see. As we move toward the deep drift phase, we allow the visual details of the web to fade, leaving only the feeling of its structure. You are suspended in this web, held in place by the collective gravity of the entire universe. There is no up or down, only the gentle pull toward the nearest node of light. This suspension is the ultimate form of rest. You are supported by the very fabric of reality, a structure that is billions of years old and will last for trillions more. The black holes are the anchors of this support, the silent pillars upon which the entire cathedral of space is built. We step back one final time until the entire observable universe is a single, glowing sphere in the palm of our mind. Within this sphere, the black holes are the dark seeds from which the light of the galaxies grows. They are the beginning and the end of the stellar story, the quiet guardians of the cosmic balance. We see the loops of time and space closing in on themselves, creating a perfect, self-contained system of order and beauty. The scale expansion is complete, and we are ready to drift into the heart of the silence. The transition to the next phase is as soft as a whisper in a dark room. We move from the observation of structure to the experience of the drift itself. The facts begin to repeat, the images begin to blur, and the mind begins to settle into the rhythmic pulse of the vacuum. The universe is wide, the web is strong, and you are safe within its embrace. We move now into the deep, still waters of the cosmic ocean, where the black holes wait in their eternal, patient silence. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them, into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth, unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light-years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, Your mind is as vast as the ladder itself. We have seen the scale. We have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The Sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the Sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the Sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light-years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light-years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. To understand the cosmos, we first have to understand our own limitations. We evolved to perceive distances we can walk in a day, or see with our own eyes distances that matter for survival and navigation. A kilometer is a 10-minute walk. A mile is a 20-minute journey. These measurements are concrete and relatable because they fit into our daily lives. But the moment we look up, these human-scaled units become awkward and eventually useless. To explore the universe, we must leave behind the familiar and prepare for a scale that challenges our very ability to comprehend it. Our brains are essentially biological survival machines, fine-tuned over millions of years to solve problems on a local scale. When our ancestors stood on the African savanna, big meant the distance to the horizon or the height of a mountain. Fast was the speed of a sprinting predator or a falling stone. We developed a deep, intuitive relationship with the physical world, but it was a world restricted to a very narrow band of reality. This is our human-scale anchor. It is the comfort zone of the tangible. In this zone, we can estimate how long it takes to drive to the next city, or how many steps it takes to cross a room. We feel the weight of an object in our hands and know its mass. This grounding is necessary for life on Earth, but it acts as a mental barrier when we attempt to look beyond our atmosphere. Consider the humble meter or yard. These units are literally based on the human body, the length of a stride or the reach of an arm. When we use these units to measure a house or a street, they make perfect sense. Even when we scale up to the size of our planet, we can still, with effort, visualize it. We can imagine a flight across the ocean taking 12 hours, and our brains can loosely stitch together that duration with the physical distance covered. We can look at a globe and understand that the thin blue line of the atmosphere is fragile. But even at this stage, the anchor begins to drag. The Earth is roughly 12,742 kilometers in diameter. If you were to try to walk that distance without stopping, it would take you months of continuous movement. Already, the human scale is beginning to fray at the edges. The problem is that the universe does not operate on a human scale. It operates on a cosmic one. As soon as we leave the surface of our world, the numbers don't just get larger, they change in quality. They become abstract. When we say the moon is 384,400 kilometers away, the brain hears the number, but it cannot feel the distance. It loses the tactile connection it has with a kilometer-long walk. This is the lunar gap, the first true test of our ability to let go of our terrestrial anchors. To bridge this gap, we often use analogies, telling ourselves that you could fit 30 Earths in the space between us and the moon. We use these mental crutches because the raw data is too vast for our ancestral hardware to process. We are trying to run cosmic-scale software on hunter-gatherer hardware. This limitation isn't just a quirk of psychology, it's a fundamental challenge in how we communicate the story of space. If we cannot relate to the distance of our nearest neighbor, how can we hope to grasp the distance to the sun? The sun is 150 million kilometers away. At this point, the kilometer has become a redundant tool. Using it to measure the solar system is like trying to measure the width of the Atlantic Ocean using the thickness of a human hair. It is technically possible, but the resulting number is so large that it ceases to mean anything to the human mind. This is why we must transition into new units of thought. We have to learn to think in terms of light-time understanding that even at the fastest speed allowed by the universe, it still takes 8 minutes for a photon to travel from the sun to your eyes. By anchoring ourselves in the human experience first, we acknowledge our starting point. We admit that we are small, that our perspective is local, and that our intuition is often wrong when applied to the stars. This humility is the prerequisite for discovery. We must accept that our senses were never designed to perceive the curvature of space-time or the billion-year life cycles of stars. We are effectively scale blind. Just as a person born without the ability to see color must rely on instruments to tell them the sky is blue, we must rely on mathematics and technology to tell us the true dimensions of the void. The human anchor is also about time. We live for perhaps 80 or 90 years. To us, a decade is a significant portion of our existence. A century is ancient history. But in the cosmic script, a million years is a blink. The stars we see at night are not static. They are in violent, constant motion. But because their lives span billions of years, they appear frozen to our short-lived eyes. Our anchor in time is just as restrictive as our anchor in space. We view the universe as a still photograph, when in reality it is a chaotic, high-speed film. To understand space-themed stories, we have to mentally speed up our perception of time while slowing down our expectation of distance. Every story we tell about the stars is an attempt to pull the cosmos down to our level. When we talk about interstellar travelers or galactic empires, we are using human political and social structures to make the infinite feel intimate. We give names to constellations, warriors, queens, and animals to turn a terrifyingly vast vacuum into a familiar neighborhood. This is a necessary survival mechanism. Without the human anchor, the sheer scale of the universe would be paralyzing. It would be a total perspective vortex that could crush the human spirit under the weight of its own insignificance. But there is a beauty in this struggle. The fact that a creature whose world is measured in footsteps can calculate the mass of a black hole or the age of a distant galaxy is a testament to the power of the mind to transcend its biological limits. We are anchored to the Earth by gravity and to our history by evolution, but our curiosity is unanchored. We use the familiar, the walk, the mile, the minute, as a springboard to leap into the unfamiliar. We build mental ladders, starting with the human scale and slowly adding rungs of increasing magnitude until we can reach the stars. As we move forward into the deeper segments of the cosmic story, keep this anchor in mind. It is your point of reference. Every time we speak of a distance that breaks the brain, remember that it only breaks the brain because the brain was built for the forest and the field, not the vacuum. By recognizing the boundaries of our internal map, we can finally begin to explore the territory that lies beyond the edges. We are the bridge between the microscopic and the macroscopic. We are the observers who give the scale a name. In the following segments, we will leave the shore of the familiar. We will watch the Earth shrink until it is nothing more than a pale blue dot, and then we will watch that dot vanish entirely. We will see structures so large that they defy the cosmological principle, and we will encounter anomalies that suggest our current maps are incomplete. But no matter how far we travel, we always carry the human anchor with us. It is the "you are here" marker on the map of the infinite. It is what allows us to say, "I am small, but I am here, and I am looking." This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And, more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. To begin this expansion of our perspective, we must look at the tools we use to hold on to our reality. Think about your home. The average house is a space you can walk across in 30 seconds. You know the texture of the walls, the creak of the floorboards, and the exact distance from the front door to the kitchen. This is your primary anchor. It is a scale that makes perfect sense to your brain because you experience it every second of every day. Your brain evolved to understand these immediate, tactile spaces, areas you can see, touch, and navigate without a second thought. But when we move from the living room to the city, the anchor begins to slip. We start relying on technology, like cars and maps, to bridge the gap between what we can see and where we need to go. We are already abstracting our reality. The problem is that the leap from a city to a planet is nothing compared to the leap from a planet to the void. Imagine standing on a football field. It's about 360 feet long, a distance you could stroll across in 2 minutes. Now, Imagine laying 17 of those fields end to end. That is a mile. Comet. Kea. A mile is a distance most of us can still visualize. It's a 20-minute walk, a common measurement for a morning jog. But to reach the edge of our own atmosphere, you would need to stack 62 miles of those football fields vertically. This is the Kármán line, the invisible boundary where the sky turns to space. Even at this relatively short distance, our human intuition fails. We cannot see 62 miles up. We only see a blue haze that fades into black. This brings us to the lunar gap. The moon is our closest neighbor, sitting approximately 238,855 miles away. To a human brain, that number is just a digit on a page. To bring it back to the anchor, consider this. If you could drive a car at highway speeds toward the moon, it would take you nearly 6 months of non-stop driving to get there. No red lights, no gas stations, just 160 days of driving through a vacuum. If you chose to walk, it would take you 9 years. This is the first rung on the cosmic ladder, where the human scale starts to feel absurd. We use these analogies like fitting 30 Earths between us and the moon, not because they are scientifically precise, but because they are the only way to prevent our minds from shutting down in the face of such emptiness. Once we pass the moon, the anchor is no longer dragging, it is severed. The distance to the sun is 93 million miles. This is the solar anchor, the unit we call an astronomical unit, AU. If the moon was a 9-year walk, the sun is a walk that would take you 3,500 years. You would need 40 generations of your descendants to keep walking just to reach the light. This is why we stop using miles and start using light time. Light is the fastest thing in the universe, traveling at 186,000 miles per second. It can circle the Earth 7 times in a single heartbeat. Yet, even at this impossible speed, it takes light 8 minutes and 20 seconds to reach us from the Sunday. When you look at a sunset, you are seeing the sun where it was nearly 9 minutes ago. You are already looking into the past. This temporal shift is a crucial part of the human anchor. We are used to things happening now. If you drop a glass, it breaks now. If you call a friend, they hear you now. But in space, now is a localized concept. The further out we look, the further back in time we see. This creates a strange paradox. The larger the universe gets, the older the information we receive becomes. By the time we look at the nearest star system, Proxima Centauri, we are looking 4 years into the past. If that star were to vanish today, we wouldn't know for another 4 years. We are anchored in a present that doesn't exist for the rest of the cosmos. To understand the scale of a galaxy like our Milky Way, we have to stretch the anchor until it breaks. Our galaxy is 100,000 light-years across. If you were to scale the entire Earth down to the size of a single grain of sand, the Milky Way would still be the size of the entire United States. Think about that for a moment. Every mountain, every ocean, every city, and every person who has ever lived, all shrunk into one speck of sand, and the neighborhood it lives in is still a continent wide. This is the true scale that makes Earth disappear. We aren't just small, we are mathematically insignificant in terms of volume. And yet the Milky Way is just a mid-sized galaxy. When we look at giants like IC 1000, 101, which is 6 million light-years across. The Milky Way itself becomes the grain of sand. IC 1101 is so large it could swallow thousands of Milky Ways. It is a cosmic monster, a graveyard of galaxies that have been consumed over billions of years. At this scale, the human anchor is so far behind us that it's almost impossible to find. We are talking about structures that take millions of years just for a single particle of light to cross. If you were on one side of IC 1101 and sent a hello message to the other side, by the time it arrived, your entire species might have evolved into something else or vanished entirely. But why does this matter to us, the observers? It matters because it defines the cosmological principle, the idea that on a large enough scale, the universe looks the same everywhere. But our recent discoveries of defiant anomalies suggest this might not be true. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure is so large it shouldn't exist according to our current models of how the universe grew. It is a knot in the fabric of space that defies the smoothness we expected. These are the things that keep astronomers awake. They are the moments where our mathematical anchors fail, and we realize that the universe is even stranger than we imagined. We also encounter interstellar visitors like 3I, Atlas, or Oumuamua objects that don't belong to our sun. They come from the dark, silent reaches between stars, carrying secrets of other worlds. When we see these objects, the human anchor feels a different kind of tug. It's not just about size, it's about loneliness. We look at these drifting rocks and wonder if they were once part of a system like ours, or if they are the cold spots of a distant, dying sun. They remind us that our solar system is not a walled garden, but a porch light in a very dark forest. The human anchor is also a shield against the vast empty. Between the galaxies lie the voids, spaces, millions of light years across where there is almost nothing. No stars, no planets, just a few stray atoms per cubic meter. If you were placed in the center of the Boötes void, you wouldn't see a single star in the night sky. It would be total, absolute darkness in every direction. For a creature evolved to follow the sun and the moon, this kind of emptiness is a sensory nightmare. Our anchor helps us populate that darkness with meaning. We look at the Great Attractor, a mysterious gravitational anomaly pulling our entire region of space toward it, and we give it a name. We turn a terrifying physical force into a character in our cosmic story. Consider the smallness of our achievements. We have sent probes like Voyager 1 into the interstellar medium. It has been traveling for nearly 50 years at 38,000 miles per hour. In human terms, that is incredibly fast. In cosmic terms, it hasn't even left the front yard. It will take Voyager 40,000 years to reach the vicinity of another star. This is the reality of the distance that breaks our brains. We are a species that lives for decades, trying to conquer a universe that operates in eons. However, there is a flip side to this insignificance. If the universe is so large and we are so small, then the fact that we can understand it at all is a small miracle. We are an arrangement of atoms, carbon, nitrogen, oxygen forged in the hearts of dying stars. We are literally stardust, that has come together in such a complex way that it can now turn around and study the stars that made it. The universe is looking at itself through our eyes. When we calculate the distance to a quasar or the mass of a supermassive black hole, we are the universe's way of knowing itself. The human anchor isn't just a limitation, it's a perspective. Without the anchor, size has no meaning. A galaxy is only big because we know what small feels like. The vacuum is only empty because we know what a crowded city street feels like. We provide the contrast. We are the yardstick by which the infinite is measured. Every space-themed story, whether it's about a journey to Mars or the collision of two galaxy clusters, is ultimately a story about us. It's about how our human hearts react to the cold, beautiful indifference of the stars. As we continue to explore, we must be prepared for our anchors to be tested again and again. We will find impossible stars that are older than the universe itself. We will hear strange signals from the deep that might be natural or might be something else. We will see giant circles in the sky that hint at events from before the Big Bang. Each time, we will try to drag our human scale units, our kilometers and our miles out into the deep to make sense of it. And each time, they will fail us, forcing us to grow, to adapt, and to build a bigger anchor. The human anchor is our starting point, but it is not our destination. It is the solid ground we stand on before we take the leap. We must respect our limitations, but we must never be imprisoned by them. We are the bridge builders. We bridge the gap between the grain of sand and the galaxy. We bridge the gap between the 10-minute walk and the billion-year journey. So, as we move into the next segments of this general script, as we look at the true scale, the light years, and the anomalies, remember the anchor. Remember the smell of rain on pavement, the warmth of the sun on your skin, and the simple reality of a 1-mile walk. Hold those things close. They are what make the vastness of space worth exploring. They are the reason we look up in the first place. We don't go into the dark to get lost. We go into the dark to find out just how bright our own small light truly is. We have grounded ourselves. We have acknowledged our size. Now, we are ready to leave the shore. The horizon is calling, and though it is further than it looks, we have everything we need to begin the crossing. The universe is vast, but it is also ours to observe. And that, in the end, is the most human anchor of all. When we think about the solar system, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. We look at a map of the planets, and our brains instinctively try to shrink the cosmos down into something manageable, something that fits on a kitchen table or a classroom poster. But the reality is that the solar system is not a collection of objects. It is a collection of distances. It is an exercise in emptiness, punctuated only occasionally by the smallest specks of matter. To understand where we are, we have to first understand how much where there actually is. Imagine, for a moment, that you are going for a walk. You know the weight of your footsteps on the pavement. You know how long it takes to walk to the end of your street or to the local park. If you walked at a steady, brisk pace for an entire hour, you would cover about 3 miles. In our daily lives, 3 miles is a substantial distance. It is enough to change the scenery, to move from a busy downtown to a quiet suburb. But in the context of the solar system, that hour of walking hasn't even moved you the width of a single hair on the scale of the worlds we are about to discuss. To truly grasp the human-scale perspective, we must use an analogy that strips away the confusing billions of miles and replaces them with things you can visualize. Let us use the grapefruit analogy again, but let's walk through it slowly, feeling every step of the journey. Imagine you are standing in the center of a vast, empty salt, flat, level ground, stretching to the horizon in every direction, silent and still. In your hand, you hold a grapefruit. This grapefruit represents the Sunday. It is warm, it is bright, and it represents 99.8% of all the matter in our entire solar system. Everything else, the planets, the moons, the asteroids, and you, make up that tiny remaining 0.2%. Now, place that grapefruit on a small pedestal in the center of the salt flat. To find the Earth, you have to start walking. You aren't just stepping back a few feet. You walk past the first planet, Mercury, which is a tiny pinhead just 5 yards away from the grapefruit. You keep walking another 5 yards to find Venus, another pinhead. Finally, you reach a distance of about 15 yards, roughly the length of a large school bus, and you stop. There, on the ground, you place a single grain of salt. This is Earth. This grain of salt is your home. Everything you have ever known, every person you have ever loved, every war ever fought, and every dream ever dreamt has occurred on that tiny, crystalline speck sitting 15 yards away from a grapefruit. The first thing that strikes you in this silence is the space. Look back at the grapefruit. From the perspective of your grain of salt, the grapefruit looks small. It's about the size that the actual sun appears in our sky. But look at the ground between you and the grapefruit. There is nothing there. No cosmic dust clouds, no crowded asteroid fields. Just 15 yards of empty air. If you were an ant standing on that grain of salt, the distance to the grapefruit would seem like an infinite journey. Now, let us continue our walk. We want to find the outer reaches of the neighborhood. To reach Mars, the red pinhead, you walk another 7 yards. You are now 22 yards away from the Sunday. The distance is growing, and the grapefruit is looking smaller now. But we are still in the inner circle. To find the next planet, Jupiter, you have to be prepared for a hike. You leave the inner planets behind and start walking across the salt flat. You walk past the 30-yard mark, the 40-yard mark. You keep going until you are nearly 80 yards away from the grapefruit, almost the entire length of a football field. There, you find a cherry tomato. This is Jupiter, the king of the planets. Even though it is the largest planet, compared to the grapefruit, it is still just a small piece of fruit, and the distance between your grain of salt and this cherry tomato is 65 yards of absolute nothingness. As you stand by the cherry tomato and look back toward the center, the grapefruit is now a small dot in the distance. Your home, the grain of salt, is invisible to the naked eye. You are beginning to feel the true scale. But we aren't finished. To reach Saturn, you have to double your distance again. You walk until you are 140 yards away from the grapefruit. To reach Uranus, you walk to 280 yards. By the time you reach Neptune, the final major planet, you are nearly 450 yards away, more than a quarter of a mile from where you started. Stand there for a moment at the Neptune marker. You are a quarter mile away from a grapefruit. If you look back, you cannot see the grain of salt that is Earth. You can barely see the grapefruit. The solar system that we see on posters as a crowded family of planets is, in reality, a vast, lonely desert where the participants are so small and so far apart that they almost don't exist. This challenges how we think about our place in the world. We feel big, we feel important, but on the scale of the grapefruit and the salt flat, we are essentially a ghost. The silence of this perspective is not meant to make you feel insignificant in a negative way. Rather, it is meant to provide a sense of profound relief. All of the pressures of your daily life, the deadlines, the worries about the future, they all exist on that grain of salt. And that grain of salt is safely tucked away in a corner of a quarter-mile wide field of peace. Scientists understand this scale, not just through distance, but through time. If you wanted to send a message from your grain of salt to the cherry tomato of Jupiter using light, the fastest thing in the universe, it would take about 40 minutes for the message to arrive. If you were Neptune and you wanted to call Earth, you would have to wait 4 hours for your hello to reach home and another 4 hours for the reply. The solar system is a place where even conversation happens in slow motion. What makes this strange is not the distances themselves, but the fact that gravity manages to hold it all together. That grapefruit, all the way back at the center, is pulling on the speck of dust that is Neptune nearly half a mile away, with enough strength to keep it in a perfect, steady circle. It is a delicate, invisible clockwork. As you imagine yourself standing on that salt flat, the sun beginning to set, the grapefruit glowing faintly in the distance, you can feel the air grow still. You are a human-scale observer in a cosmic-scale reality. You are small, yes, but you are the only thing in this quarter-mile radius that is capable of understanding the map. You are the mind that holds the grapefruit and the salt grain together. For now, that understanding is enough. You don't need to walk any further tonight. You can simply stand here, in the quiet of the salt flat, and realize that the scale of the universe is not a wall, but an invitation. It is an invitation to let go of the small things and embrace the vastness. With that in mind, let's move outward once more, to an even larger scale. This is where the human brain begins to feel the first gentle tug of the impossible. We have spent our lives navigating a world where a 5-mile hike is a morning's commitment and a cross-country flight is a significant journey. But as we step away from our grain of salt and our grapefruit, we have to abandon these units of measurement. They no longer serve us. They are like trying to measure the depth of the ocean with a thimble. To move forward, we must change our pace, transitioning from the physical act of walking to the mental act of drifting. Think about the speed of a commercial airliner cruising at 500 miles per hour. At that speed, you can cross an entire continent in an afternoon. It feels fast. You look out the window and see the clouds racing by, the landscape shifting beneath you. But if you were to fly that same plane from our grain of salt toward the sun, you wouldn't arrive for 21 years. You would spend 2 decades in the air, flying day and night, just to reach the nearest star. This realization is the first scale reset. It forces us to acknowledge that the empty space we often ignore is actually the most dominant feature of our environment. As we continue to expand our perspective, we encounter the first major boundary of our planetary neighborhood. In our everyday lives, we are used to boundaries that are clear: a fence, a shoreline, a city limit. In space, boundaries are more like gradients, where the influence of one thing slowly fades as the influence of another begins to take hold. We are moving toward a scale where the gaps between objects are so large that the objects themselves start to feel like accidental interruptions in a much larger story of stillness. Consider the moon, our closest neighbor. In most diagrams, it sits just a few inches away from the Earth. But on our human scale, if the Earth were a basketball, the moon would be a tennis ball located 30 feet away. Think of that empty 30-foot gap. You could fit every other planet in the solar system, Jupiter, Saturn, the ice giants, all of them, side by side, inside that single gap between the Earth and the moon, and you would still have room to spare. This is the lunar gap, and it is our first true lesson in cosmic density. We live in a universe that is incredibly efficient at being empty. As we drift further, the numbers begin to lose their edges. We talk about millions of miles, but the human mind treats a million the same way it treats a billion as a lot. To stay grounded, we must return to the feeling of time. Imagine a clock that ticks only once every century. On the scale we are entering, that clock would seem to be moving quite fast. The solar system operates on a rhythm that ignores the frantic pace of human history. The mountains on our grain of salt rise and fall in the time it takes for the outer planets to make just a few laps around the Sunday. Scientists understand this slow-motion reality by looking at the human-scale anchors that still exist within it. We look at the light that reaches us from the Sunday. That light, traveling at 186,000 miles per second, takes 8 minutes to cross the 15 yards of our salt-flat model. When you step outside and feel the warmth of the sun on your skin, you are feeling energy that left its source 8 minutes ago. You are always living in the past, seeing the sun not as it is now, but as it was when you were perhaps just starting a conversation or finishing a cup of tea. This delay is a constant reminder that distance and time are woven together. What makes this strange is not that the universe is big, but that it is so sparsely populated. We are used to a world of constant stimulation noises, lights, people, traffic. But as we expand to the scale of the inner solar system, the stimulation drops to nearly zero. If you were floating in the space between Earth and Mars, there would be no sound, there would be no wind, there would be no sense of movement, even if you were traveling at thousands of miles per hour. Without a nearby object to provide context, speed becomes an abstract concept. You are simply there, suspended in a vast, dark cathedral of light. Astronomers didn't expect the vacuum to be quite so profound until they began sending probes across these distances. They found that space isn't just empty. It is a vacuum more perfect than anything we can create in a laboratory. It is a place of total preservation. A footprint on the moon stays there for millions of years because there is no weather to wash it away. The scale of the solar system is also a scale of permanence. On Earth, we are used to things breaking, rusting, and fading. In the vastness between the worlds, things simply endure. And for now, that endurance is simply part of the picture. It provides a sense of stability. As you continue to drift in your mind, let the vastness of these gaps act as a blanket. There is so much room in the universe for everything to simply be. There is no crowding here. There is no rush. Every planet has its own vast territory, millions of miles of private space in which to perform its slow, ancient dance. We often feel the need to fill silence with words or empty spaces with objects. But the solar system teaches us the value of the void. The void is not a lack of something, it is a thing in itself. It is the stage upon which the planets play. It is the dark velvet that makes the stars shine. By embracing the human-scale perspective of this emptiness, we can begin to let go of our own need to constantly be doing. We can transition from being actors to being observers. To understand the scale of the outer system, we need to step back even further. If our quarter-mile salt flat represented the distance to Neptune, the distance to the next nearest star, Proxima Centauri, would be another 2,000 miles away. Imagine that. You have a grapefruit in one city, and the next grapefruit isn't in the next neighborhood or the next town. It's on the other side of the continent, and in between, nothing, just thousands of miles of empty salt flats, with the occasional grain of salt or cherry tomato drifting in the dark. This challenges how we think about the neighborhood of our Sunday. We aren't just in a large space, we are in a staggering isolation. But this isolation is what makes our small grain of salt so remarkable. In a continent of empty flats, a single grain of salt that holds life, water, and consciousness is a miracle of the highest order. The scale doesn't diminish us, it highlights us. It provides the contrast necessary to see how special the stuff of the universe really is. As we move toward the next phase of our journey, allow your breathing to slow down, matching the rhythm of the planets. You are no longer walking, you are no longer flying, you are simply expanding. The boundaries of your room have faded, the boundaries of your city have disappeared. You are now as large as the orbit of the Earth, circling the Sun in a slow, silent loop that takes an entire year to complete. There is no tension in this movement. It is the natural state of things. Everything in the solar system is falling, but it is falling in a way that perfectly balances its forward motion, creating the eternal circle of the orbit. It is a state of perpetual grace. You can feel that same balance in your own rest. You are supported. You are in motion, even when you are still. You are part of the clockwork. With that in mind, let's move outward once more, to an even larger scale, where the rocky worlds end and the giants begin. Where the light grows dim and the silence grows even deeper, we are leaving the inner circle, the warm hearth of the sun, and moving into the great, cool expanses of the outer dark. But do not worry. The scale will continue to guide us. The distances will continue to protect us, and the stillness will be our companion. Now let's slowly expand outward. One level beyond what we just explored lies the neighborhood of the inner planets: Mercury, Venus, Earth, and Mars. In the grand design of the cosmos, these are the rocky worlds. They are solid. They have surfaces you could, in theory, stand upon. They represent the high-density center of the sun's domain, a place where the gravity of our star is so intense that it has cleared away the lighter gases, leaving behind only the heavy elements, the iron, the silicate, and the nickel, to form these four small, resilient spheres. To understand the inner circle, we must first look at Mercury. It is the closest to the flame. If our sun is the center of a cosmic hearth, Mercury is the stone sitting directly in the embers. It is a world that has been stripped down to its essentials. It has no atmosphere to speak of, no clouds to shield it from the sun's relentless gaze. Because it lacks an atmosphere to trap heat, it experiences the most dramatic temperature swings in the solar system. By day, the surface is hot enough to melt lead, By night, it plunges into a frozen darkness more bitter than any winter on Earth. Scientists understand Mercury by observing the way it interacts with the Sun's magnetic field. It is essentially a giant ball of iron, a planetary core that seems to have lost its outer layers in some ancient, forgotten collision. It orbits the Sun with a strange, wobbling rhythm, completing 3 rotations for every 2 revolutions. It is a world that refuses to be tidally locked, yet it is forever bound to its master. As you consider these 50 or so stars nearby, let your mind drift away from the details. Imagine them as small, steady lanterns, hanging in a very large, very dark room. They are far apart, they are mostly dim, and they have been there for billions of years. They are the first step on a journey that will eventually take us to numbers that break the brain. But here, in the neighborhood, the lights are still few enough to count, if you have the time. With that in mind, let's move outward once more, to an even larger scale. As we drift further away from the familiar warmth of our Sun, we begin to realize that the neighborhood is far more crowded than it appears, yet far emptier than we can imagine. We are leaving behind the terrestrial measurements of miles and kilometers, entering a realm where the only meaningful yardstick is the light year, the distance light travels in a single Earth year, roughly 6 trillion miles. To understand the number of stars nearby, we must first accept that our eyes are only tuned to the high-performance engines of the cosmos. We see the giants, the burners, and the beacons, but the true census of our local space is written in the dim, the small, and the patient. When we look out into the 16 light years surrounding our home, we find a curious demographic. We expect to see stars like our Sun, yellow, vibrant, and life-giving. But of the 50 or so stars in this immediate vicinity, the vast majority are red dwarfs. These stars are the introverts of the universe. They are often less than half the size of our Sun and significantly cooler. If our Sun is a roaring bonfire in a dark forest, a red dwarf is a single glowing ember. This brings us to a staggering realization about the count. The universe is not made of the bright things we see, but of the dim things we overlook. Scientists understand the prevalence of these stars by using infrared surveys, peering through the cosmic noise to find the heat signatures of these small suns. What we know so far suggests that for every star that makes it into our mythology and our constellations, there are 10 more that are too shy to be seen. In our local neighborhood, this means that even if you had a telescope in your backyard, most of your neighbors would remain invisible to you. They are there, huddled in the dark, burning their fuel so slowly that they will still be shining long after our Sun has expanded into a red giant and faded into a white dwarf. But the count doesn't stop with the stars that successfully ignite. One level beyond the red dwarfs lies a category of objects that challenges our very definition of what a star is: the brown dwarfs. Often called failed stars, these objects are the middle ground between a massive planet like Jupiter and a small star. They are too heavy to be planets, but too light to sustain the nuclear fusion that allows a star to shine with its own light. Astronomers didn't expect to find so many of these objects drifting through the solar neighborhood. They move through the dark, like rogue wanderers, glowing only with the leftover heat of their formation. Because they are so difficult to detect, the actual number of objects in our neighborhood might be double or triple what we currently estimate. Every time we launch a new, more sensitive space telescope, we find more of these dim travelers. What makes this strange is not what we see, but what we don't understand about their distribution. Are they as common as the stars themselves? Do they outnumber the planets? To understand why the number of stars breaks the brain, we have to look at the density, or rather, the lack of it. Even with 50 stars and potentially hundreds of brown dwarfs within 16 light-years, the volume of space they occupy is so immense that they almost never interact. Imagine a volume of space so large that light takes 30 years to cross it from end to end. Now, imagine placing 50 marbles inside that space. The chances of one marble ever meeting another are practically zero. This is the isolation of the solar neighborhood. We are a collection of islands in a sea of nothingness. Scientists use the motion of these nearby stars to calculate the mass of the galaxy, but for the individual stars, the neighborhood is a place of profound solitude. Proxima Centauri, our closest neighbor, is part of a triple star system, a rare social gathering in a lonely sector. But even there, the distances between the three stars are vast enough that if you lived on a planet orbiting one, the others would still be mere points of light in your sky, not secondary suns that would warm your skin. Even with everything we've learned through missions like Gaia and WISE, there are still things we don't fully understand. We are still uncovering substellar objects that sit right in our backyard. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time, and it hides its smallest residents well. We may find that the number of stars in our neighborhood is actually much higher, populated by cool, dark suns that have been there since the beginning of the Milky Way, waiting to be noticed. And for now, that uncertainty is simply part of the picture. We don't need a final tally of every brown dwarf or dim red dwarf to appreciate the scale. The mystery itself provides a sense of continuity. It suggests that even in the parts of space we think we know best, there is more to be discovered. It doesn't need to be resolved tonight. As we rest in the knowledge of our local street, this small, quiet, suburban neighborhood of 50-odd suns and their invisible companions, we prepare our minds for the next leap. We have counted the houses on our street. Now, it is time to look at the city. We are moving from the dozens to the billions. We are moving from the neighborhood to the galaxy. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond our solar neighborhood lies the entirety of the Milky Way galaxy. If our local neighborhood was a single street, the Milky Way is the sprawling, glowing metropolis that contains it. Our galaxy is a barred spiral, a massive whirlpool of stars, gas and dust spanning 100,000 light-years from edge to edge. To traverse it at the speed of a commercial airliner would take you more than 100 billion years, a duration that exceeds the age of the universe itself. Inside this vast structure, the numbers begin to lose their grip on our intuition entirely. Astronomers estimate there are between 100 billion and 400 billion stars in our galaxy alone. To put that in perspective, consider the human heart. Over an average lifetime, a human heart beats about 2.5 billion times. You would need 160 human lifetimes to reach the number of stars in our galaxy, heartbeat by heartbeat. Scientists understand the scale of the Milky Way by measuring the speed at which stars orbit the galactic center. By observing how fast the stars on the edge are moving, we can calculate the total mass required to keep them from flying off into the void. This calculation tells us that the Milky Way is not just a collection of lights, but a massive gravitational anchor. Most of these 400 billion stars are, again, the small red dwarfs we discussed in the neighborhood, but as we move toward the galactic center, the density increases. The suburbs where we live are quiet, but the downtown of the galaxy is a crowded, violent place where stars are packed so closely together that the night sky would be as bright as the day. What we know so far suggests that our sun is just one average star, located in a quiet, unremarkable arm of the galaxy called the Orion Spur. But even with everything we've learned, there are still things we don't fully understand. We don't know the exact number of stars in our own galaxy, and we likely never will. The reason for this is extinction, not the biological kind, but the cosmic kind. The Milky Way is filled with vast clouds of gas and interstellar dust. These clouds act like a thick fog, blocking our view of the other side of the galaxy. When we look toward the center of the Milky Way, we see a wall of darkness. Astronomers must use radio waves and infrared light to see through this fog, but even then, millions of stars remain hidden from our view. What makes this strange is that we are trying to count the residents of our own house while standing in a dark hallway with a flickering flashlight. Beyond the flat disk of the galaxy lies the halo, a spherical region that surrounds the Milky Way like a ghostly envelope. This halo contains globular clusters, which are ancient, tightly packed balls of stars. Some of these clusters contain 1 million stars in a space only a few dozen light-years across. They are some of the oldest objects in the universe, remnants from the very beginning of the galaxy's formation. Astronomers didn't expect these clusters to be so stable. They have survived for over 12 billion years, orbiting the galaxy like moths around a street lamp, but the number of stars in the halo is difficult to pin down. There are rogue stars out there as well, stars that have been kicked out of the galactic disk by gravitational interactions and are now drifting into the intergalactic void. Are they still part of the Milky Way? Or have they become citizens of the nothingness? And for now, that uncertainty is simply part of the picture. Whether there are 100 billion stars or 400 billion, the result for the human mind is the same, a sense of profound, quiet insignificance. It doesn't need to be resolved tonight. We can accept that we live in a city so large that we haven't even seen most of the buildings. The Milky Way is our home, but it is a home of such scale that we are like a single ant in a skyscraper. The 400 billion stars are not just numbers. They are potential suns, potential solar systems, and potential histories. They are the backdrop of our existence, the massive structure that holds our little solar neighborhood in place. As you contemplate the 400 billion lights of the Milky Way, let your breathing slow. Imagine the galaxy spinning slowly, majestically taking 230 million years to complete a single rotation. We are currently on a journey around the galactic center, traveling at 500,000 miles per hour, yet the galaxy is so large that we feel perfectly still. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond our galaxy lies the local group. This is a collection of about 50 to 80 galaxies that are gravitationally bound together. While 400 billion stars in the Milky Way seemed like an ending point, it was actually just the beginning. In the local group, the Milky Way has a sister, the Andromeda Galaxy. Andromeda is larger, more massive, and contains an estimated 1 trillion stars. A trillion. That is a 1 followed by 12 zeros. If you were to count to 1 trillion, one number every second, you would not finish for 31,700 years. You would have started counting during the last ice age, before the invention of agriculture, and you would only be finishing today. Scientists understand the local group by tracking the motion of these galaxies as they slowly dance around one another. Despite the expansion of the universe, the Milky Way and Andromeda are actually moving toward each other. They are falling into each other's gravitational embrace at a speed of 250,000 miles per hour. What we know so far suggests that in about 4 billion years, these two giants will collide and merge to form a single, even larger galaxy, often nicknamed Milkomeda. This collision won't be a violent crashing of stars. Remember how much empty space there is, but a slow, beautiful blending of two massive stellar populations. The number of stars in our immediate vicinity will effectively double, but even with everything we've learned about our local group, there are still things we don't fully understand. Scattered between the Milky Way and Andromeda are dozens of dwarf galaxies. These are tiny galaxies, some containing only a few million stars. They are the pebbles scattered around the two boulders of our neighborhood. Many of these dwarf galaxies are so dim and diffuse that we are only just finding them. They are being slowly cannibalized by the Milky Way and Andromeda, their stars being stripped away and added to the larger galaxies' totals. This challenges how we think about the number of galaxies. Is a dwarf galaxy still a galaxy if it is being torn apart? How many of these tiny neighbors are still hiding in the glare of the larger ones? The local group represents a boundary. Beyond this group, the expansion of the universe is pulling galaxies away from us. But within the local group, gravity has won. We are tied to these other galaxies for the rest of time. The trillions of stars in Andromeda, the billions in the Triangulum galaxy, and the millions in the dwarf clouds, they are all part of our cosmic tribe. And for now, that uncertainty regarding the total number of members in our group is simply part of the picture. It doesn't need to be resolved tonight. We are part of a family of galaxies, a small cluster of light in a much larger dark. As you drift further into this thought, imagine the local group as a cluster of campfires in a vast, dark tundra. Each campfire is a galaxy, and each spark in that fire is a star. There are millions of sparks, all huddling together against the encroaching cold of deep space. With that in mind, let's move outward once more, to an even larger scale. Now let's slowly expand outward. One level beyond our galaxy lies the local group. This is our cosmic neighborhood on a grander scale, a collection of about 80 galaxies huddling together in the dark. If the Milky Way was a city, the local group is the county. It spans about 10 million light years across. Most of the members are dwarf galaxies, small clusters of a few million stars, but the group is dominated by two giants, our Milky Way and the Andromeda galaxy. Andromeda, also known as M31, is our closest major neighbor, located 2.5 million light-years away. While the Milky Way is impressive with its 400 billion stars, Andromeda is a true behemoth. Estimates suggest it contains 1 trillion stars. A trillion is 1,000 billion. If our galaxy is a city, Andromeda is a sprawling megastate. Scientists understand the local group by tracking the redshift and blue shift of these galaxies, the way their light changes as they move. What we know so far suggests that despite the overall expansion of the universe, the Milky Way and Andromeda are actually moving toward each other. They are locked in a gravitational dance that will eventually lead to a collision. But because stars are so far apart, as we learned in our human-scale anchors, the stars themselves will likely never hit each other. Instead, they will pass through like ghosts, eventually settling into a new, massive elliptical galaxy. The number of stars in our immediate clump will double, creating a sky filled with a density of light we can barely imagine. But even with everything we've learned, there are still things we don't fully understand about the local group. For years, computer models of the universe predicted that there should be thousands of small, satellite galaxies orbiting the Milky Way and Andromeda. However, when we look through our telescopes, we only find a few dozen. This is known as the missing satellite problem. Astronomers didn't expect the neighborhood to look so empty compared to their theories. Are these galaxies made of dark matter and thus invisible to our eyes? Or have they been swallowed up by the giants already? What makes this strange is that the more we look, the more we realize that our count of total stars in the local group is likely missing millions of residents who live in these dark, diffuse dwarf galaxies. These are the rural areas of our cosmic county, vast spaces where stars are few and far between, hidden in the shadows of the giants. The local group is our final anchor in the sea of expansion. Every galaxy beyond this group is moving away from us, pushed by the mysterious force of dark energy. But here, within the local group, we are held together by the familiar force of gravity. The trillions of stars in Andromeda and the billions in our own Milky Way are our permanent companions in the dark. And for now, that uncertainty about the missing satellites or the exact star count in Andromeda is simply part of the picture. It doesn't need to be resolved tonight. We are not alone in the void. We are part of a small, huddling family of galaxies. The cycle of observation continues as the telescopes on Earth and in orbit remain pointed at the sky. Data streams back in a steady, rhythmic pulse, filling hard drives with the ghosts of distant gravity. New black holes are discovered in the hearts of small, dim galaxies that were once overlooked by us. Each discovery adds a small piece to the grand puzzle of how the universe is put together. The light from the accretion disks continues to travel across the void, reaching our senses in time. We analyze the curves of space-time, seeking to understand the subtle shifts in the fabric of reality. Somewhere in the distance, two black holes are spiraling toward each other in a long, slow dance. They orbit a common center, sending ripples through the universe known as gravitational waves in a pulse. These ripples are like the rings on a pond, spreading outward at the speed of a silent light. They carry the news of a cosmic union, a merging of two greats into a single entity. This process takes millions of years to complete, a testament to the patience of the deep cosmos. The waves pass through us, through the Earth, and out into the beyond without a single sound. The stars continue their orbits around the central dark, a choreographed movement that spans the entire galaxy. Gravity holds everything in a delicate, persistent grip that ensures the continuity of the celestial machine. We are part of this machine, moving with the Earth as it follows its own path through space. The black holes remain, silent and watchful, as the eons pass by in a slow, steady stream. There is no end to the learning, no final page in the book of the wide universe. We simply move from one observation to the next, drifting deeper into the understanding of the dark. The light of the stars remains a constant companion in the long, quiet nights of our shared history. To understand the nature of this continuation, we must look at the way gravity never truly lets go. It is a long, invisible thread that connects the smallest moon to the largest supermassive black hole. Even as we drift into the deepest parts of the night, this thread remains taut and steady. The Earth does not fall away into the void, and the sun does not wander aimlessly from its path. Everything is held in a state of perpetual, graceful motion. This motion is the pulse of the universe, a rhythmic heartbeat that has no beginning and no end. You are part of this pulse, a quiet vibration in the great web of space-time. As you drift further, the concept of a final discovery begins to feel like a distant and unnecessary thought. We realize that the universe is not a problem to be solved, but an experience to be inhabited. The black holes are the quiet anchors of this experience, providing the weight and the depth that make the light so precious. They sit at the centers of their galaxies, watching the birth and death of stars with an indifference that is both ancient and soothing. Their silence is not an absence of sound, but a presence of stillness. It is the kind of stillness you find at the bottom of a very deep and very clear mountain lake. In the infinite ending, we see that every ending is merely a transition into a new form of existence. When a star falls into a black hole, its mass is not destroyed. It is added to the singularity, contributing to the gravity that holds the galaxy together. This is a form of cosmic memory, a way for the universe to preserve the essence of its creations. The black hole is a vault, a repository of matter and energy that spans the entire history of the cosmos. We can find comfort in the idea that nothing is ever truly lost, only stored in a different, more permanent state. The dark is a safe place for the stories of the stars to reside. The movement of time itself becomes a loop in this final phase of our journey. We return to the ideas of the accretion disk, the event horizon, and the singularity, seeing them now as familiar landmarks in a landscape we have come to know. Each time we revisit these concepts, they feel more natural and less daunting. The black hole is no longer a mystery to be feared, but a part of the natural order, as predictable as the seasons on Earth. We accept the curves of space-time as easily as we accept the curves of a river or the slope of a hill. The universe is a home, and the black holes are its most stable and enduring foundations. Imagine the universe as a vast, repeating pattern, like a fractal that reveals the same beauty at every scale. From the tiny particles that pop in and out of existence at the event horizon to the grand rotation of the galactic clusters, the same laws are at work. There is a consistency to this design that is deeply reassuring. You do not need to worry about the rules of reality changing while you sleep. The gravity that holds the stars will also hold you. The black holes are the guardians of these rules, the physical evidence that the universe is a coherent and logical system. They are the constants in an ever-changing world of light and energy. As the narration fades, the facts about black holes become less about information and more about atmosphere. We talk of the $110 facts not as a list to be memorized, but as a series of gentle reminders. We remind ourselves of the slowing of time, the bending of light, and the immense scales of the deep time. These reminders act like the steady ticking of a clock or the rhythmic sound of waves on a shore. They provide a structure for the mind to rest upon, a sequence of thoughts that lead inevitably toward a state of perfect, undisturbed quiet. The infinite ending is a place where the words stop, but the understanding continues. We see the black holes as the ultimate expression of nature's patience. They do not rush to consume the galaxy. They wait for the stars to come to them in their own time. They do not hurry their own evaporation. They allow the Hawking radiation to drift away over trillions of years. This patience is a model for our own rest. We can let go of the urgency of the day, recognizing that the most important processes in the universe take place over timescales we cannot even imagine. We are allowed to be patient with ourselves, to move slowly through our thoughts, and to fade into the background of the cosmic story. The light of the stars remains a constant companion, even as we move deeper into the understanding of the dark. We see the distant glow of quasars, the bright flashes of supernovae, and the steady radiance of our own sun. These lights are the markers on our journey, the guides that show us the way through the vastness of the void. But we also recognize the beauty of the spaces between the lights, the quiet and empty stretches where the black holes reside. The darkness is not a void to be filled, but a canvas upon which the light is painted. It is the essential counterpart to the bright and the visible. In this infinite ending, there is no signal that the story is over. The narration simply becomes a part of the ambient sound of the universe, a low and steady hum that continues in the background of your consciousness. The black holes remain, the stars continue their orbits, and the space continues its silent expansion. The celestial machine moves on, and we move with it, drifting deeper and deeper into the quiet reaches of the dark. There is no goodbye, only a continuation of the journey, a steady progression from one state of being to another. The universe is wide, the night is long, and the rest is complete. Everything is as it should be. The gravity is holding, the light is bending, the time is stretching. You are part of the machine, part of the loop, and part of the infinite. The black holes are the anchors, the stars are the companions, and the dark is the home. We move forward into the silence, knowing that the story will repeat, the patterns will hold, and the universe will remain a place of wonder and peace. The long, quiet nights of our shared history are just beginning, and the future is a vast and open field of stars. We drift, we rotate, we remain. The steady stream of eons passes by, and we find ourselves at home in the flow. There is no final page, only the turning of the next and the next, in a book that is as large as the universe itself. We accept the mystery, we embrace the dark, and we find rest in the continuity of the celestial machine. The black holes are the silent watchers, and we are the silent observers, moving together through the eternal, rhythmic, and hypnotic dance of the deep cosmos. In this final phase of our journey, the distinction between the observer and the observed begins to soften. You are not merely a listener to these facts. You are a participant in the gravitational reality they describe. The same forces that govern the event horizon are present in the very atoms that compose your being. As you drift, consider the concept of the eternal return. The idea that in a universe of such vast scale and infinite time, every possible configuration of matter will eventually repeat. The black hole is the master of this repetition, recycling the energy of ancient stars into the faint, thermal radiation of the future. It is a slow, steady heartbeat that ensures the heart of the universe never truly stops beating. Imagine the universe as a grand, circular gallery where the exhibits are the stages of cosmic evolution. As you walk through this gallery, you notice that the end of one hallway leads directly back to the beginning of the next. There is no exit, but there is also no sense of being trapped. Instead, there is a profound sense of belonging. The black holes are the pillars that support the roof of this gallery, standing firm as the exhibits around them change. They are the constants that allow the variables of life and light to exist. By accepting this loop, you find a freedom from the linear pressure of time. You are no longer moving toward an end. You are simply moving within an infinite presence. Think of the way a deep, quiet forest breathes at night. The air is still, but if you listen closely, you can hear the subtle movements of life in the undergrowth, the rustle of leaves, the distant call of an owl, the soft sigh of the wind. The empty space of the galaxy is much like this forest. It is alive with the movement of neutrinos, the vibration of gravitational waves, and the steady influence of dark matter. The black holes are the ancient trees of this forest, their roots reaching deep into the fabric of space-time, providing a sense of age and stability. You are a traveler resting at the base of one of these trees, feeling the immense safety of its presence as the stars move slowly overhead. The concept of nothingness is replaced by the concept of potential. Within the dark center of a black hole, the laws of physics as we know them may be transformed into something new. Some theorists suggest that every black hole contains a new universe, a baby cosmos born from the extreme density of the parent. This idea creates a chain of existence that stretches beyond our own observable horizon, an infinite lineage of space and time. Even if we can never see these other worlds, the mere possibility that they exist adds a layer of richness to the darkness. The black hole is not a grave, but a womb, a place where the seeds of new realities are held in a state of perfect, quiet preparation. As the eons pass, the light of the stars becomes a memory, and the universe enters the era of the black holes. This is a time of ultimate refinement, where the chaotic energy of the early universe has been distilled into its most stable and concentrated forms. In this era, the movement of a single particle is a symphony, and the collision of two black holes is a cosmic event of unparalleled scale. Yet, to an observer, it would all seem perfectly still and silent. This is the peace of the infinite ending, a state where the magnitude of the events is matched only by the depth of the stillness. You are drifting into this stillness now, letting the vastness of the future carry you away from the noise of the present. Consider the way a master weaver works at a loom, repeating the same motions over and over to create a complex and beautiful pattern. The universe is such a weaver, and gravity is the thread. The black holes are the points where the thread is most tightly knotted, providing the tension that gives the tapestry its form. As you look at the tapestry from a distance, you no longer see the individual knots. You see only the flow of the design. You are a part of that design, a single thread that is woven into the infinite pattern. The repetition of the weaver's hands is the same repetition we find in the orbits of the stars and the cycles of the singularities. It is a movement that brings comfort through its consistency. In this state of rest, the 110 facts we have explored are no longer items of information to be processed. They have become part of the background radiation of your mind, a soft hum that provides a steady anchor for your dreams. You know that the time slows, that the light bends, and that the dark is full of history. These truths are as reliable as the ground beneath you, even as you drift through the weightless void. The black hole is the ultimate guardian of these truths, holding them in a vault of gravity that can never be broken. You can trust the universe to keep its secrets, and you can trust yourself to find peace within the mystery. The transition from the deep drift to the infinite ending is so gradual that you may not even notice it has happened. You are simply here, in a state of eternal being. The black holes remain. The stars continue their slow, choreographed dance, and the eons flow by like a river of glass. There is no need for words, for the silence of the cosmos says everything that needs to be said. The darkness is a soft, warm blanket that tucks you into the fabric of the night. You are home. You are safe. You are part of the infinite. The loop is now complete, and as it repeats, it brings with it a deeper and more profound sense of rest. The facts will return, the scale will expand, and the drift will continue, but you will remain in this state of perfect, quiet existence. The universe is a book with no final page, and you are the silent reader, turning the pages of the stars with a peaceful and steady hand. The light of the shared history remains, and the dark of the future is a welcome friend. We move together now into the heart of the eternal, where the black holes watch over the silent, rhythmic dance of the deep cosmos. Everything is as it was, and everything is as it will be. The gravity holds, the light bends, the time stretches into infinity. You are the observer, you are the dancer, and you are the dark. The rest is absolute, the peace is permanent. The story goes on, forever and ever, in the quiet, hypnotic reach of the black hole. Good night.